Okay, hi guys, this is the last calculus video of Unit 5, and this is to be watched Tuesday, January 31st. And there is going to be no homework that corresponds to this video, and the topic is using long division to find an antiderivative. And guys, you want to use long division to find an antiderivative so please write this down, if the degree of the numerator is greater than or equal to the degree of the denominator. And the fact that I'm saying degree, okay, we want these to be polynomials, the numerator and denominator. We want it to be a rational function whose numerator and denominator are polynomials. That's the only way that long division would work. Okay, so if you've got, for example, this example 1, the antiderivative of x to the third plus x polynomial over x minus 1, another polynomial. And the degree of the numerator is 3, because that's the highest exponent involved. And the degree of the denominator is 1, because that's the highest exponent involved. So, guys, if the degree of the numerator were less than the degree of the denominator, let me flip back a couple of days, then you want to try to use this formula. This was on page 20. Okay, so that formula would have worked because here were the notes from that day. We used that formula because up here, the degree of the numerator is 2, the degree of the denominator is 3, and then we did a little further investigation. If we let the denominator be f of x, the numerator was f prime of x. And then we could use that formula. But here, don't even bother to check and see if the numerator is the derivative of the denominator, because it can't be, because the degree is higher. When you take the derivative, you go down a degree. So what you want to do is try to use long division to rewrite this function so that you can find its antiderivative using rules that we know. Okay, so if you don't remember long division, so I'm going to do a little review here, but if you don't remember it, you should YouTube videos about long division. I might actually have some pre-calculus ones that are already up. So I could look and see, and then I could tell you, if you don't remember this. Okay, so so I want to take x to the third plus x. Notice I'm missing some terms here. So I'm missing the x squared term, and I'm missing the constant term. So I'm going to take the numerator and I'm going to write it as x to the third plus 0x squared plus x plus 0. All right, so I wrote down the numerator, and then I'm having all of the terms. All the missing terms have a coefficient of 0. And then I'm going to divide this by the denominator, x minus 1. Okay, so hopefully this will refresh your memory, and if not, try to look up some videos on it, and I'll see if I have a pre-calc one up already. So I ask myself, so I do x to the third divided by x. In other words, what do you multiply x by to get x to the third? That's the same question I just asked in a different way. And the answer is x squared. So I put it at the top of the x squared column. And then I multiply this back, I distribute this back out to that binomial. So x to the second times x is x to the third. X to the second times negative 1 is negative x squared. And then you subtract. Okay, so those are canceling. And then we will end up with positive x squared. Okay, because it's 0x squared minus a negative 1x squared. So we get positive x squared. And then you bring down the next term. And you do it again. X times what makes x squared? X, so plus x. And then you multiply, you distribute this back to these. So we get x to the second minus x. And then you subtract that. Those cancel, and here we get 2x, bring down the next term. And then you do it again. X times what makes 2x plus 2. And then you distribute that back out. So this is 2x minus 2, and then you subtract it. And those cancel, and then you get a remainder of positive 2. Okay? So, guys, what we just figured out is that the function on the inside here we could rewrite this integral because this function is equivalent to this, x squared plus x plus 2 plus the remainder over, I think that's called the divisor, or the dividend, I always forget. Okay, so this function here that we're finding the antiderivative of, we just use long division to rewrite it as this. Notice that all of these terms you could just use power rule to find the antiderivative of, and this one now the degree of the numerator is 0 and the degree of the denominator is 1. So we have the degree of the numerator less than the degree of the denominator, so we can probably use that formula. Okay, so there's that. Now, okay, so let me section that off. Okay, so now I'm going to split up. If you're taking the antiderivative of a sum, it is the same as the sum of the antiderivatives, and we can group the sums however we want. So instead of going antiderivative of this plus antiderivative of that plus antiderivative of that, etc., I'm just going to do the antiderivative of this trinomial here because we're going to use the same rule for all of them, which would be power rule. So I'm going to go antiderivative of x squared plus x plus 2 dx plus the antiderivative of 2 over x minus 1 dx. Okay, so these I'm just going to be using power rule on. But this one here, I'm going to use that formula that is back on page 20. Let me flip back to it for the second time in this video to remind you. This formula that you want to know here, we're going to try to use that. So you could use that formula if the degree of the numerator is less than the degree of the denominator, which in this case it is. So you let f of x be the denominator, and then you take its derivative, which in this case is 1. So I want a 1 to be up here, and I've got a 2 up there. Well, guys, this is easy. I could just move the 2 out front with the constant multiple rule, and then I would have a 1 up there. So now I'm finding the antiderivative of everything. So this here, I'll just use power rule. So it's going to be 1/3 x to the third plus 1/2 x squared plus 2x. Okay, so that's the antiderivative of this first part, plus bring down that constant multiple 2, natural log of the absolute value of x minus 1, and then you could just do the plus c at the end, because c stands for any constant, so it doesn't matter if we have like a c here and then another c there. We could just have one big c at the end. So this is the family of functions whose derivative is what we started with. Alrighty, so there's that. Let's do an example where the degree of the numerator is the same as the degree of the denominator, because that's another situation where we could use this method. So let's flip to the other side. And here is example number 2. We're going to do the antiderivative of x minus 5 over negative 2x plus 2. The degree of the numerator is 1, because that's the highest exponent involved. The degree of the denominator also 1, okay? And then you don't have to flip to the front, but let me. Because remember, we could use long division if the degree of the numerator is greater than or equal to the degree of the denominator. So I'm going to do the same thing that we did before. I'm going to take the denominator, and no, other way around. My bad. I'm going to take the numerator and divide it by the denominator. Okay, I wasn't missing any terms here. It goes right from x to the first to x to the 0. So I didn't have to fill in any terms with the 0 coefficient. Alrighty, so I ask myself, negative 2x times what makes x? And the answer is negative 1/2. Okay, so I multiply negative 1/2 by those. I distribute it there, and we end up with x minus 1, and then we subtract, and then those cancel, and then we get negative 5 minus negative 1, which is negative 5 plus 1, which is negative 4. So that's the remainder. Okay, so back up here, this is equal to the antiderivative of negative 1/2 minus 4 over negative 2x plus, wait, am I doing this right? Yeah. Yes, I believe so. Yes. Alrighty, and then that's dx. Okay, and then I'm going to split this up. This is just a constant, so I can use the power rule on that. Or just the fact that, never mind. Okay, so this is going to be the antiderivative of negative 1/2 dx minus the antiderivative of 4 over negative 2x plus 2 dx. Okay, so I'll focus on this one here because that's the quotient, and I'll let f of x equal negative 2x plus 2. So f prime of x is negative 2x. No, just negative 2. So I want this to be a negative 2, this numerator. So I'm going to do two things to accomplish that. First, I'm going to move that negative inside, so I'll change that to a plus negative 4. And then I'll think of this 4 as a 2 times 2, and I'll move one of the factors of 2 out front. And I'll change it. Okay? So that's how I've rewritten it. And if you're having trouble with that, please do your best to understand it on your own, and then if you still can't, come see me. Okay, so this, now I can find the antiderivatives of everything. So this is equal to negative 1/2 x. The antiderivative of a constant is just the constant times whatever variable you're finding the antiderivative with respect to. Or you could think of this as negative 1/2 x to the 0, and then you add 1 to 0 and then divide by it. And then so bring down that plus sign, carry down the 2, and then this is the natural log of the absolute value of negative 2x plus 2, and then plus c at the end. Guys, that was the last video of Unit 5. We've only got 2 units left for this year, and they're going to be pretty fast. So this is going great, and I will see you soon. Bye-bye.